Hi everyone, we're H2No. We're a part of Section F with Dr. Wheeler, and we're doing the rotary biomass dryer. This is all of us. We're a team of four. We're just built different. We're just better like that. So this is our problem description. Our team was tasked with drying wet biomass quickly and efficiently. It needs to be around 15% moisture content by weight. We only have a maximum budget of $230. It's designed with the intent of mass production and/or industrial production as well. Prototypes must weigh less than 50 pounds and must not be a fire hazard and must operate in a safe manner. And the team ultimately decided to go with a rotating drum dryer. As you can see in the video right now, we have all of our components running. We have our motor spinning. We have our serpentine belt turning the drum. We have our tensioner. We have our power supply and our Arduino in that little white box over there. And we also have our little humidity sensor, all of which we'll talk about in the future.
We considered around 4 designs when starting this project. We ended up with the rotary dryer because of the pros that it gave to us, which was it could be easily altered for commercial use as per the metric that we needed. We can either have it on a smaller scale like we had, or we can push it up to a commercial scale. And it moves around in spins, which allows for greater agitation and efficiency while drying. It can additionally be compacted and fit within our restrictions for our prototype, which is good for us. And it can also be portable for showing different stakeholders. It's the most viable option out of all of them, considering the efficiency and speed, especially with the volumetric area need to be heated. And it offers a more evenly dried and isotropic dried material. The cons of this is the agitation fins were hard to fix, and it used to be just an even bigger problem in production. So a different method has to be found for that. And the materials available with our budget could melt or overheat, considering we were using something like PLA for our materials for combining things together. Since this is a rotary drum, we needed to make sure that this was going to heat up while it was rotating. So first we need to calculate the heat transfer flow coefficient for the actual material itself. From going to the PTC heater to the air, we are able to calculate that Q value and then actually going from the air to the biomass. Once we found the wattage needed for that biomass, it was going to have to then rearrange that convection flow heat transfer coefficient rate to go get the mass. For a around 30-minute runtime, we got a mass of 2 pounds for thin fibers and around a 3-pound capacity for thick fibers with a little bit longer of a runtime.
The electrical components that were really running the show was the Arduino Nano and the SHT31D temperature and humidity sensor. This allowed both for monitoring of the temperature and humidity within the drum, but also allowed for PID control of the heat inside the drum so that we didn't overheat it. The drum itself was made from a 24 by 24 inch 22 gauge A36 steel sheet. It was rolled and then riveted together. There were also steel fins that were plasma cut and then bent and riveted into place to allow for movement of the biomass along the length of the drum depending on which direction the drum was spinning. The motor we chose was from Robot Zone. It was a 20 RPM 12-volt motor. It has a planetary gear reduction for increased torque and has a stall torque of 17 inch-pounds, which is more than enough to rotate the drum without any worrying of slippage.
The biggest consideration for when selecting our materials was whether or not it can retain heat and will it not be negatively impacted by heat. So we chose sheet metal because it matched the requirements and also is readily available. Nylon also because it's heat resistant, so we wouldn't worry about it melting and impacting the system. Through testing, we found that on average it takes about 30 to 40 minutes for a full drum of material to be dry. And it takes about 15 minutes for it to reach about 90 degrees Celsius. By the end of the dry, the moisture levels will be about 15-20% by the weight of the material. We also found that sawdust will dry much faster than mulch, and that the agitation fins will help break up any material as it spins it back and forth to the drum. And if we had more time, some improvements that we would implement was to help create better sealant so that less heat is escaping, same with the biomass leaking through the ends of the drum, that we would just have a more reliable transfer system for power, that the installation for the agitation system for the fins inside was very difficult, so we'd make an easier system to install. Installation in general, just make it more efficient and have higher quality of sensors and just improve the system in general.